Okay, so today's opener is just a review of past lessons. The directions say consider each equation. Determine whether the function has a maximum or a minimum value. Then we're going to state what that value, what that value is. And then we are going to find the domain and the range of the function, then find the equation of the axis of symmetry and graph the function. So we have a lot we're going to do here. So let's take a look at the first one. So you have y equals negative x squared minus 4x minus 4. So let's determine the first thing that it's asking. Does the function have a maximum or a minimum? Maximum. And if you recall, it has a maximum because we're looking at, in standard form, we're looking at the first term, the a term, to see if it's a positive or a negative. If it's a negative, it's going to have a maximum. So does that mean the graph is going to open up or down?
Down.
So the graph is going to open down, which it didn't ask that, but I'm going to go ahead and put that in there. Now, we need to find the maximum value. So we answered the first part. Now we need to state the maximum value. What do we need in order to determine what the maximum value is?
X.
The x tells me the axis of symmetry. So I'll have to find the x, but what's the end result that I'm looking for?
Vertex.
The vertex. What specifically in the vertex do I want?
X value.
Not the x value,
X-intercept.
not the x-intercept, the y. Because remember, the y tells us how high or how low a line's going to be, and that's what's going to tell us the maximum point. Okay, so I don't have the x or the y value. So I'm going to have to find the x value and the y value in order to get an ordered pair. So Ben said at first I'm going to find the x value. How do I find the x value? Ben, how do I find the x value?
You gotta do x equals negative b over 2a.
Which gives me the axis of symmetry. Okay, so what do I substitute for my b?
Negative 4.
And then I have 2. And what do I substitute for my a?
Negative 1.
Negative 1. Any questions on where these numbers came from? Okay, negative touching becomes a positive. And then 2 times negative 1 is
Negative 2.
4 divided by negative 2.
Negative 2.
So my x value equals
Negative 2.
negative 2. So far my x value for my vertex is negative 2. Now, I need to find my y value. So how do I find my y value? What's the next step that I'm going to have to do? How do I find my y value, you guys?
You get a substitute.
Substitute. So when I see that x, what do I put in place of the x?
2.
Not 2, but
Negative.
negative 2. All right. So when I go ahead and I use PEMDAS or order of operations to simplify the equation, where do I start?
Negative 2 squared.
Which is
Negative 8.
negative 2 times negative 2,
4,
positive 4. But then because I have the negative in front of the parentheses, I bring that down. Then what's negative 4 times negative 2? So I'm right here. Negative 4 times negative 2. What is that going to equal?
Positive 8.
Positive 8. And then I bring down my minus 4. All right, when I simplify this, I'm going to have negative 4 plus 8 minus 4. What's negative 4 plus 8 minus 4?
0.
0. So my y value is 0. Okay, so can I state the maximum value now? Can I state my maximum value?
Yep.
Yeah. So I'm looking at, as my maximum value, what's that going to equal?
Negative 2 comma 0.
No. My maximum value is just the y part of my ordered pair. So what's my maximum value?
0 comma 0.
Just straight up 0. Okay? The next thing it's asking, it's telling me to determine what the domain and the range of the equation or the function. So what's the domain? Domain is all real numbers. Very good. And the range?
Y is y greater than or equal.
No, I disagree. It's maximum.
No.
So y is?
0 is greater than or equal to
Y is what? What inequality sign do I use?
Less than or equal to?
Less than or equal to, and then what was our maximum?
Yeah, that way.
What was our maximum?
0.
0. Okay, we already found the axis of symmetry. So the last thing that we're going to do now is graph it. So I'm going to graph this here. So I have my vertex that I could go ahead and graph. So what's my vertex?
-2.
-2, 0. Okay, so there's my vertex. What other point do I refer to in order to help me graph? I did not write it down, but what else do I like to use in order to get me my other point to plot on my graph? I have my vertex, but that's all I have. But I know I can refer to my function and get another point to plot. What else can I use from this function in order to get an order pair for another point to plot? What is this number used for? Not x. The y-intercept. So how would I write my y-intercept?
0, 0.
How would I write my y-intercept?
0, -4.
-4, good. So I could go ahead and plot that point. Okay. Now remember, my axis of symmetry runs right through my vertex. If I'm going to graph this, I need another point that's going to be symmetrical to my y-intercept. So what's another point that's going to be symmetrical to my y-intercept? And this is what we kind of focused on a little bit more yesterday. Maddie, what did you get?
Something on the side 2.
So say what?
Or point. It's 2.
So you went over 2 more from the axis like that?
Yeah.
So what would that ordered pair be?
-4, -4.
-4, -4, good. And then we graph it. There we go. So today what you guys are going to do is that you're going to graph this and then you're going to solve the quadratic by graphing. Okay? So I'm going to give you a quadratic. We're going to find the same information, except for this time we're going to be looking for our roots or a y-intercept or our solution, or excuse me, not a y-intercept, our x-intercept or a solution to get our answer. Now, how many times does this parabola cross the y or the x-axis? Yeah, once, just right here. So it only crosses the x-axis once. Okay, so that would only have one solution. All right, let's go ahead and look at the second example problem. Second example problem is just like the first, okay? It's just like the first. We're looking for the same information. So the first thing that we're going to do is the exact same thing that we did on the other one. We found the axis of symmetry, because the axis of symmetry allows me to find what my x value is so that I can then substitute it to find my y value. Danny, tell me how to get my axis of symmetry.
You have to do x equals -b over 2a.
Okay. And what do I substitute for that b?
2,
And what do I substitute for a?
1.
Which then equals?
-2 over 2,
Then equals?
1.
Close.
Okay, -1.
-1. Okay. Now I want to find my y. Logan, how do I substitute to find my y? So I'm going to use y equals,
Negative and -1
squared
squared
plus 2 times what?
plus -1
And then,
plus 3.
very good. Okay. So then what's -1 squared? Anybody? -1 squared?
Positive 1.
Okay. Then 2 times -1?
Negative 2.
Then plus 3. If we keep simplifying that, what's 1 minus 2 plus 3? So 1 minus 2 plus 3.
2.
2. Okay. So then what's my vertex?
Negative 1, comma 2.
So I get -1, comma 2. So that's my vertex. I'm going to use that. Now, with that, I found out quite a bit of information about this. So looking at the function, does it have a maximum or a minimum?
Minimum.
Okay, and it has a minimum. What's my minimum value going to be?
0.
No, it is not an ordered pair. Your minimum value is not an ordered pair.
2.
Just straight up 2. Good. Okay, so now we've answered, we found the maximum and minimum value. We stated that it had a minimum. So now we're going to find what's the domain and range. So what's my domain? All real numbers. Okay. What's the range?
Y. Okay.
Okay, so now it has a minimum. So what inequality? Good. Greater than or equal to. And then what was your minimum?
2.
2. All right. So now we're ready to graph the function. But you and I both know from our previous problem, so far I can only plot the vertex. So what's my vertex that I'm going to plot?
Negative 1, 2.
Okay, so my vertex is going to be right here. My axis of symmetry runs through that vertex. So I know I'm going to have symmetrical points on my coordinate plane in order to plot my parabola. Now, how can I get another ordered pair to plot? What can I look at to get another ordered pair to plot?
I don't know. You can use the 3.
Which is the,
Y-intercept.
okay, so we're going to use this 3, referencing back to my 9.3 notes. I know this is t value. My standard form is going to be the y-intercept. So what's my y-intercept? Ben said it's going to be 0, 3. Okay, so if I want a symmetrical point using the axis of symmetry, what's the other point that I'll plot then? So if I'm here, and I want to be able to fold it over on the dotted line and have another point that would be reflecting my y-intercept, I would plot my other point right here. What would that ordered pair be for that plot, or for that point?
Negative 2, 3.
Good. And then my parabola, I'm going to make sure that I graph it so that it's opening up. And it shows a nice, good curve.